Welcome to this tutorial about integration by substitution. So in the past you may have looked at anti-differentiation, the main step being, increasing the power by 1 and just simply dividing by that power and getting the antiderivative. Sometimes expressions do tend to get a little bit more complex than simply having a single variable on its own. So sometimes you might be integrating sine, cos, or other expressions where that may not necessarily be very possible for you to just increase simply the value of x up by 1, etc. So we do need another type of method to integrate, and a really good one, a really popular one, is integration by substitution. Now, it's only relevant for specialist maths, so you would never be actually asked this in maths methods. To actually use this method, you're going to have to substitute the more complex equation with variable u. Of course, you can make that variable whatever you want, but u is the standard. So the following are the steps of integration by substitution. So we'll go through these steps as we go through the example. So the first step is to identify the variable u. So as I mentioned, u is the most complex part of the expression. So I think in this equation, cos squared x is probably the most complex looking part of that equation. So we're actually going to let u be equal to cos of x. And notice how I didn't actually include the squared. And that's just because I want to keep it simple. I want to make my u substitution simple. I'm still going to have a squared on the u, but I'm just going to keep u as simple as possible. So then the second step, so this is our first step. The second step is actually a differentiation step. So you may be thinking, okay, hang on, what's differentiation doing in integration? And that's totally valid to think, to be a little bit confused. The main purpose is that it's actually going to form a relationship between dx and du. Because eventually, what you're doing in this expression, I'm going to take out factorize the 2 and 5 just to make things easier. So what you've got in this expression is, this. Now what we're going to do is we're going to replace, eventually, because we're making a substitution of u here, so we're allowing that to be u, we can't have the ending being dx. We need it to be du. So we're going to have to replace that dx with du. So what we're doing by differentiating, so we are actually forming a relationship between du and dx. And so du over dx, the derivative of cos is minus sine. And so I'm just going to form a relationship to find an equation like so. So I know that du is the same as minus sine x dx. And that will become more important as we go through this integration process. So what we're going to do in the third step is we're going to actually change the differential in terms of du. So at the moment, our differential is dx. And so what we're going to have to do is just simply change that into u squared, and then change, you can see that all of this sine x dx, well, here we can see that if we just move that negative over to the other side, sine x dx is actually minus du. So we're going to replace that with minus du, the whole thing. And by doing so, I'm actually going to bring that minus up the front. By doing so, we've got u squared in terms of du. Okay, so now we've got our correct variables, So we can just integrate like normal, using, increasing our power by 1. So that will become u to the power 3 over 3, and then plus c. And that will become negative 2 on 15. And u cubed is cos. U was cos. So I'm just going to put that back in. And that's the antiderivative. So that's the first example. So that was, I put example 4. Step 4 was probably this one, so we have to actually antidifferentiate it. Step 3 was this one here, where we replaced the sine x dx with minus du. And then we had step 5, which is just expressing the final expression in terms of x. Okay, so let's have a look at the next example. Question 2, it says, find the antiderivative of the expression that. So once again, what I'm going to do is I'm just going to replace it, I'm going to take out the minus 2, put it on the outside, and I'm actually going to take out a 3 from the denominator there. So what we're left with is 1 over x squared plus 2x plus 7 over 3. By taking out the 3 from that denominator, I'm actually going to have to divide each of the terms by 3. So by doing this, now I can see that I've got an expression there, and I can't really make u the denominator in this case. And that's because when I differentiate it, let's say I made u equal to all of that, I will get, when I differentiate, I'm actually going to get an expression of the derivative in terms of x. And I don't have an x to replace. So I'm a little bit stuck. What I'm going to do is probably complete the square. So I can't really make an appropriate substitution just yet. So we're going to complete the square of this expression of the denominator. So x plus 1 squared plus 7 over 3 take away 1. And then we've got x plus 1 squared, and that's going to be plus 4 on 3. And so what we've got now is minus 2 on 3. The denominator part is just going to be x plus 1 squared plus 4 on 3. And the top part is just 1. Now this is starting to look like the integral of tan. So remember when we integrated an equation in terms of this, we had tan inverse of x over a plus c. So this is what we're going to be using in this expression, because it's the same, it's in the same form, but one of the things is the denominator might not be as clear to kind of see. So what we're going to do is we're going to let u be equal to x plus 1, and then we're going to say, okay, du over dx is equal to 1, and du equals to dx. Okay, so I have sort of run away from space, or run out of space, not away with space, that would be quite difficult. And so I'm going to bring the expression here. Integral of 1 over u squared plus 4 on 3, and I can replace that with du. And now what I'm going to do is, we know that a squared is equal to 4 over 3, and therefore a is equal to 2 over square root of 3. And so we really need to introduce the value of a at the top of that denominator, at the top of that fraction. So 2 over square root of 3 goes at the top. U squared plus 4 over 3 goes at the bottom. And then on the outside there, we need to remember, you can't just add in a random number into your expression without getting rid of it. So we need to times by the reciprocal. So square root of 3 over 2. You can't just add in 2 over square root of 3 without timesing it by the inverse of that. Because by timesing it by the inverse, we actually will end up maintaining that 1 there. So that's quite important. All right, so now the next step is this and this cancel, and we get a minus square root of 3 over 5. And I will just go straight to the integration of this. There will be a tan inverse of u divided by 2 over square root of 3. Okay, so negative square root of 3 over 5, tan inverse of square root of 3 over 2, and then u. Now u in this case is just going to be x plus 1. And we've got plus c. So that is our antiderivative of the expression. So we did have to use a substitution, but it wasn't as clear from the very beginning. So we do need to, one of the things that I've just noticed that I've done, silly mistake, is I've actually somehow managed to get distracted as I was talking about space, and I made that 5 for some reason, so I'm going to fix that up. So divided by 3, and that will mean that this number in front of here changes. Okay, so that's going to be 3, and that's going to be 3. Okay, so that's the correct answer now, hopefully. So let's have a look at the next question. Question 3. Find the antiderivative of the expression. Okay, so we've got another one of these cases, and I think that looks a bit like an inverse function, inverse trigonometric function. However, we will again try our very best to, hang on, I've lost my pen. Okay, so we just need to, integral of 2 over 5 square root of 10x minus 24 minus x squared dx, 2 on 5, 1 over all of this. Now I'm just going to arrange it, making the x squared first, followed by 10x, followed by minus 24. And now I'm going to complete the square. So I need to complete the square of that denominator there. And before I can do anything, I'm just going to take out the minus. And then I'm going to focus on actually completing the square. So we've got x minus 5 squared plus 24, take away 5 squared. So what I'm actually doing here is just working out, so minus 1 minus x minus 5 squared. Okay, so we get 2 on 5. One minus x minus 5 squared dx. So what is happening now is we should be making a substitution. So let u equal to x minus 5. And let's say that du over dx is now equal to, well, it's just 1. So du is the equivalent of dx. And so we've got 2 over 5, integral of 1 over 1 minus u squared, and du. So now this is the same as the sine inverse. So basically we need to replace all of that with sine inverse of u over 1 plus c. Okay, and that's just going to become sine inverse of u. Now u was x minus 5. So that's our antiderivative. Okay, let's have a look at question 4. So question 4 states, find the antiderivative of this. So we've got to find the antiderivative of this. Again, you wouldn't really do this by just increasing the power by 1, dividing by the new power. You just can't do it that way. So we'll again make a substitution. So we'll let, in this case, we're going to let u equal to the more complicated part. So that's x minus 1. And we, again, are going to differentiate. So that's just going to give us 1. So du is equivalent to dx. Okay. So we've got that. Now, what we're going to do is we're going to replace the denominator, this part here, with just u squared, and replace the dx with du. Now, the top part, we can't really leave it as 2x minus 1 because it's the variable here is in terms of u, and you're only allowed to have u at the top there. So what we need to do is we need to find a way to rewrite, rewrite 2x minus 1 in terms of u. And so we know that we've got u being equal to x minus 1. We can find an expression for x in terms of u. And then we know that the function that we want to rewrite, 2x minus 1, we can write it out in terms of u by just replacing the x with what x stands for. And we expand that. To u plus 1. So that is actually what we'll place up here, to u plus 1. And so we've now got to, we've got everything working nicely. All our expressions are in terms of u only. And so we got antiderivative 2u over x squared plus 1 over, no, it's not x squared, it's u squared, 1 over u squared du. And we've got this. And I'm going to just move the power up. So that will make it a negative. Now, the integral of 2 over u is 2 log e of u. And then that's going to be plus increase the power by 1, divide by the new power, and then plus c. And so putting that up there, and replacing, well, first of all, I'm just going to write it up in u, but I'm going to write the minus 1 over u plus c. Remember that that power is negative, so it's going to get put to the denominator, and there's a negative 1 in front, so that plus will turn into a minus. And so sub in u being equal to x minus 1, and so we've got 2 log e of u minus 1 over x minus 1 plus c. So that's our expression there. Okay? So that is the antiderivative. Okay, so the lucky last question. Not sure what I just did, or where my question is gone. Our question is gone. So down here. Okay, so it says find the antiderivative of this. So we're going to find the antiderivative of all of this. So very similar process. Let u equal to the more complicated bit, which I will make the content under the square root. Differentiate it. And du is equal to dx. And so we know that must be square root of u, and dx is the same as du, so we don't have to worry about it. We do need to worry about what we're going to do with that x squared. So find x squared in terms of u. So that's our goal. Now, we know that if we rearrange that equation, u plus 1 is equal to x. And if I make that x squared, well, I have to put a squared around all of this. Okay? So I'm going to replace this part with u plus 1 squared. And now what I'm going to do is just expand that bracket and multiply it by u to the power of a half, which is the equivalent of square root of u. Now, what we have here is we're going to be expanding that out, just using normal good old FOIL method there. So what we're doing is we're going u squared times by u to the power of a half, and remember, in this case, our indices laws, it's just going to be u to the power of 5 on 2. So I'm just expanding all of this. So that's power of 1, remember. And if we go to u to the power of 1 times by u to the power of a half, we get 2u to the power of 3 on 2. Okay, and in the next step, we have to just increase the power by 1. So increasing the power by 1, 7 over 2, divided by the new power. So that's going to be 5 over 2 divided by the new power. And so you will realize a trick here. When you get these kinds of fractions, you can just write the reciprocal of the fraction straight on the outside. So 2 over 7, u to the power of 7 over 2, plus that 2 down there and this 2 up here are going to multiply. So that's going to be 4 over 5, u to the power of 5 on 2, plus 2 over 3, u to the power of 3 on 2 plus c. Okay, so now we have to just allow u to be equal to what it is, and that is, we made it equal to x minus 1, didn't we? So we've got this. That's a 5. Plus 2 over 3. So that's what it looks like. So that's the integral of the expression. So integration by substitution can be a very powerful method to know. It can be sometimes challenging to recognize, but with enough practice, you'll find that it gets easier. So keep on practicing your exercises, and stay tuned for the next tutorial, which looks at using definite integrals in integration by substitution. Thank you.